The reaction with ketones are going to be the same as with aldehydes. The only difference is that we don't have anymore the oxidation to a carboxylic acid because I already have two carbons attached to my ketone. I cannot oxidize to a carboxylic acid. But all the additions that we saw with aldehydes are going to be the same. So let's start with lithium aluminum hydride. If you take a ketone and you reduce it with lithium aluminum hydride, remember please that it's a two-step process here. I am going to reduce the double bond to a single bond between the carbon and the oxygen, and the reaction will produce a secondary alcohol. Sodium borohydride can also do the exact same reduction. Remember, sodium borohydride is only good for ketones and aldehydes, so we might as well just use it in this chapter. We are going to get the exact same secondary alcohol we get with lithium aluminum hydride without the hassle of having to worry about moisture in the air. Let's react with an organometallic. I like Grignard, so let's use a bigger Grignard. Let's go ahead and use a 4-carbon chain. In the Grignard, it doesn't matter which halide you have, so you're going to see bromide, chlorides, and iodides. But what matters is that this carbon right here is negative, so this carbon can attack the carbonyl. So that's all we're doing is attacking the carbonyl and making, in the process, the tetrahedral intermediate. So this time around, I have 1, 2, 3 carbons attached to my carbonyl already. And I am attacking with 1, 2, 3, 4. So I am adding more carbons to my carbonyl. This is my tetrahedral intermediate. And the oxygen needs a hydrogen. So it will get a hydrogen whenever we quench the reaction. So if you notice, when you attack a ketone with a Grignard, the alcohol that we get is a tertiary alcohol. Let's use an organolithium. Let's use phenyllithium. There's an organometallic bond right here, a carbon-metal bond. That's again what we refer to as organometallic. But what's important is that the carbon is negative, so the carbon will attack the carbonyl. I have a phenyl ring already on my compound, and 3 carbons, 1, 2, 3, and I am attacking with a second phenyl ring. At this point you can just put pHs for the phenols. This is my tetrahedral intermediate. Whenever you attack with an organometallic or lithium aluminum hydride, you really need to quench because that oxygen is going to need to have a hydrogen, and the only way that's going to get a hydrogen is by adding the acid or the water. Let's protect it. Let's use the ethylene glycol. I'm going to put the ethylene glycol in a different way. I'm going to actually use the condensed formula. You need to get used to seeing it in different ways. With a little bit of the tosic acid. I kind of ran out of space here, so let me just draw it over here. We're going to attach the 2 oxygens to the carbon of the carbonyl. That's an acetal now. And our carbons are connected. So we formed a little 5-member ring. One more reaction that we did not do with the aldehyde. We can do it with aldehydes, I just didn't have space in the page. I'm going to react it with sodium cyanide. And I'm going to use, we need a little bit of acid for this. A little bit of HCl gas. can do it. A little bit of sulfuric acid will do it too. The cyanide is a good nucleophile, so it's going to attack the carbonyl. So I'm going to get an OH, well, I'm going to get the tetrahedral intermediate. And I have the acid right there because this oxygen needs a proton, so the HCl gas, the HCl, it's going to actually give me the proton that I need. This is called a cyanohydrin. And when you have a cyanohydrin, we use it because you can actually just maybe lose water so that you can get a double bond there, and then hydrolyze the cyanide or hydrogenate the cyanide. So these are not the only reactions of ketones and aldehydes, but we're going to have some more, so keep watching.